In the beginning, there was no sky, no stars, just silence. And then light. From that first breath of the cosmos, the universe has been unfolding, not just out there, but within us. The iron in your blood, the oxygen in your breath, forged in stars that lived, died, and became you. Maybe the entire process is to realize that we are a part of the universe, not apart from it, so that the universe can finally begin to know itself. If that thought stops you for a moment, stay with us. The story only gets deeper.
Have you ever just looked up at the night sky and kind of felt that overwhelming sense of awe, And it's that moment when you wonder, how did it all begin?
It's a question that's captivated philosophers, scientists, and dreamers for centuries. It's a story of cosmic proportions, a tale that connects each of us to the vast narrative of the universe.
Okay, so I remember learning about the Big Bang in school, but it was too confusing, to be honest, far too abstract. Like, how do you even visualize it?
Well, imagine this. Imagine everything in the universe, all the matter and energy squeezed into a space smaller than an atom.
Wow, that's tiny.
Exactly. And then in an instant, this tiny point began to expand rapidly, cooling as it grew. And that's the Big Bang in a nutshell.
So, it's not like an explosion in the traditional sense, right? It's more like an incredibly rapid expansion of space itself.
And the evidence for this expansion comes from something called redshift, from the Doppler effect.
Oh, I remember that. Isn't this when sound is squeezed or stretched?
Exactly.
Think of it like an ambulance or a police car with its siren on. As it moves towards you, the sound waves are compressed, but as soon as the car goes past, the sound changes as the source of it is now moving further away, and the sound waves are being stretched.
Oh, I see. So we can consider the Doppler effect with light. When galaxies are moving toward us, they shift to the blue end of the light spectrum. But when they are moving away, the light from distant galaxies stretches, shifting towards the red end of the spectrum, the redshift.
But how did we even figure this out? Who first realized this? And what does it mean for our understanding of the universe?
That's a great question. The credit goes to an astronomer named Edwin Hubble. Back in the 1920s, he was working with the largest telescope of the time at the Mount Wilson Observatory in California. Using this powerful instrument, he made an astonishing discovery.
Wasn't it Hubble who first figured out that what people thought were just fuzzy stars were actually entire galaxies?
Before his work, many astronomers believed that the universe consisted of just the Milky Way galaxy. Hubble's observations showed that these fuzzy patches called nebulae were actually other galaxies far beyond the Milky Way.
That must have been a game changer. But how does this tie into the idea of the expanding universe?
Well, Hubble went further. He measured the light coming from these distant galaxies. He noticed something fascinating. The further away a galaxy was, the more its light was redshifted, meaning it was moving away faster.
So he provided the first evidence that the universe is expanding. That's pretty mind-blowing. Did Hubble come up with an explanation for this?
Not at first. Hubble's observations gave us the data, but the theoretical framework came from earlier ideas by Georges Lemaitre, a Belgian physicist and priest.
Lemaitre proposed that the universe might be expanding, and Hubble's discovery provided the observational proof.
Together they laid the groundwork for what we now call the Big Bang theory.
That's incredible.
So, Hubble not only discovered galaxies, but also gave us evidence that the universe itself is expanding.
No wonder the Hubble Space Telescope is named after him.
Absolutely. His work opened a new chapter in astronomy and cosmology, helping us understand that the universe is far larger and more dynamic than anyone had imagined.
Wow! If the universe is expanding, does that mean we could run time backward to figure out where it all started?
Funny you should say that, Ben. That's exactly what Stephen Hawking once suggested. He said, if the universe is expanding, then it may be possible to imagine running time backwards like a movie in reverse. Galaxies would get closer together, eventually collapsing back to a single point, a singularity where density becomes infinite and our present laws of physics break down.
That's both fascinating and a little unsettling. So everything, all of us, started from a single point.
That's the implication. A singularity where space, time, energy and matter were all compressed together before the Big Bang set everything in motion.
And all of this just from observing the light from distant galaxies. It's amazing how much the universe can tell us if we know how to look.
That's the beauty of science. One observation can completely change our perspective. And Hubble's discovery of redshift was one of those pivotal moments in our quest to understand the cosmos.
So the farther away a galaxy is, the faster it seems to be moving away from us.
That's the gist of it. It's like baking a loaf of raisin bread. As the dough rises, the raisins, representing galaxies, move further apart. An expanding universe.
Okay, that's a pretty tasty analogy. I like that one.
Yeah,
So we've got this expanding universe filled with mostly hydrogen and helium gas.
correct.
How do we get from these gas clouds to the twinkling stars we see at night?
Well, gravity is the cosmic sculpture at play here. These vast clouds of gas spread across unimaginable distances have a tiny bit of gravitational pull towards each other, and over millions of years, this pull causes the clouds to slowly contract.
So it's like a slow-motion cosmic ballet with these giant gas clouds gracefully drawn together by gravity's invisible hand.
A poetic way to put it. And as the gas cloud collapses, it starts to spin like a figure skater pulling their arms in.
Oh, interesting.
Yeah. And this spin helps to distribute the angular momentum and prevents the cloud from collapsing too quickly.
So it's not just a simple collapse. There's like a choreography to it.
Absolutely. And as the cloud contracts further, the temperature and pressure at its center increase dramatically, eventually reaching a point where something truly remarkable happens: nuclear fusion.
Nuclear fusion, the powerhouse of stars.
Precisely.
Can you remind us what's happening at the atomic level during this process?
Sure. So, imagine hydrogen atoms, the simplest elements in the universe, one proton and one electron, being squeezed together with such force that they fuse to form helium. This fusion releases an incredible amount of energy, and that's the very energy that makes stars shine.
So stars are like giant ongoing fusion reactors converting hydrogen to helium.
That's a great way to think about it.
Incredible. But they don't last forever though, do they? What happens when a star runs out of hydrogen fuel?
Well, the fate of a star depends largely on its mass. Massive stars burn through their fuel much faster and end their lives in spectacular explosions called supernovae.
Supernovae, those brilliant cosmic fireworks. I've seen pictures.
When a massive star exhausts its hydrogen, it starts fusing heavier elements like carbon and oxygen in its core. And this process continues until the core becomes so dense and hot that it collapses under its own gravity, triggering a shock wave that blasts the star's outer layers into space.
Scattering those elements across the universe.
That's right. And here's where it gets really interesting. The elements on the periodic table, like carbon, oxygen, and even gold, require the immense mass, pressure, and heat of a star to form. It's in stars that atoms are pushed together, fusing protons and electrons to create these elements. All the stuff of the universe can only be made inside stars.
So it's not just a simple fade out, it's a dramatic explosive end that sends material hurtling across the cosmos.
Precisely. During a supernova, the extreme heat and pressure create heavier elements like gold, uranium, and many others. These, combined with the lighter elements from the star's outer layers, become part of the interstellar medium, the raw material for the next generation of stars.
The death of a star doesn't just mark an ending, it forms the elements that scatter across the universe, creating the building blocks for future stars, planets, and even life. It's like a cosmic recycling program.
That's such a beautiful way to put it. And here's the mind-blowing part. Those very elements, forged in the heart of stars, eventually become the seeds of new stars, planets, and ultimately, us.
Wow, as Carl Sagan famously said, we are made of star stuff.
Yeah, it's a profound thought that the universe isn't just out there, it's in us.
Every atom in your body, from the iron in your blood to the calcium in your bones, the carbon in your DNA, and the oxygen we breathe, all of this was and can only be created in the heart of a star.
We are stardust, star stuff, children of the stars.
Exactly. I've heard about that before, but it takes on a whole new meaning when you actually understand the processes that are involved.
That's right, we are intimately connected to the cosmos.
It really is a pretty amazing thought to pause on for a moment. We've gone from a tiny point of infinite density to a universe teeming with stars and galaxies, and ultimately to the very elements that make up life as we know it.
And this is just the beginning of our exploration. We've covered the Big Bang and the basics of star formation, but there's so much more to discover about the lives and deaths of stars, the diversity of stellar populations, and the ongoing evolution of the universe.
This has already been a pretty mind-expanding journey, and I can't wait to dive deeper before we move on. How do we even know about these stars if they existed so long ago?
Astronomers use a variety of techniques to peer back into the universe's distant past. One way is to look for the faintest, most distant galaxies, hoping to catch a glimpse of the light emitted by those ancient stars billions of years ago.
So we're literally pushing the boundaries of our technology and our understanding to uncover the universe's earliest secrets.
Absolutely. And as our telescopes become more powerful and we can see further, we are also able to see further back in time, collecting more data and refining our models of the early universe.
Okay, so how do today's stars like our Sun compare to those first stars? Are there any similarities?
Well, one of the most significant differences is composition. Early stars were made almost entirely of hydrogen and helium, the simplest elements. Stars today, like our magnificent Sun, which is a third-generation yellow dwarf star, contain heavier elements, which came from supernovae of those first stars when they seeded the universe with heavier elements.
Those early stars literally changed the cosmic recipe, adding new ingredients to the mix.
Precisely. And these heavier elements, they play a crucial role in star formation today. They help cool the gas clouds, allowing them to collapse more efficiently and form stars with a wider range of masses.
Like adding a pinch of salt to a boiling pot of water, it changes the way the water boils, making it more efficient.
A great analogy. And because of this, more efficient cooling stars today can form with a wider range of masses, from small, faint red dwarfs to massive, brilliant blue giants.
So the first stars were all giants, but now we have a whole spectrum of stellar sizes.
Exactly, and this diversity is crucial for the universe's evolution. Different types of stars have different lifespans and produce different elements during their lives and death, contributing to the rich tapestry of the cosmos.
So it's not just about size, it's about the elements they create, the roles they play in the grand scheme of things.
But smaller stars, like our Sun, have a different fate. They don't explode as supernovae. Instead, they gradually shed their outer layers, forming beautiful planetary nebulae.
Planetary nebulae? Do they have anything to do with planets?
They were named planetary nebulae by early astronomers because, through their telescopes, they resembled faint, fuzzy planets. But there are actually the remnants of dying stars, glowing clouds of gas expelled by a star as it reaches the end of its life. These nebulae have nothing to do with planets, but they're incredibly beautiful, creating intricate and colourful patterns in the cosmos.
So it's more like a cosmic art exhibit than a planetary nursery.
Exactly. And at the heart of these planetary nebulae lies the star's core, a dense, white, hot ember called a white dwarf. It's the final stage of a star like our Sun, a quiet, fading ember that will slowly cool over billions of years.
We've covered a lot of ground, from the Big Bang to the first stars, from stellar giants to diverse populations, from supernovae to planetary nebulae. It's been quite a journey, tracing the evolution of stars and the elements they create.
And it's important to remember that this journey leads all the way to you, to the very elements that make up your body, your planet, and everything you see around you.
That's a profound thought. We're literally connected to the universe's vast history woven from the same stardust as the most distant stars.
And this connection is not just a poetic notion, it's a scientific reality that underscores our place in the universe.
Okay, I think we've thoroughly explored the realm of stars, their birth, their lives and their deaths. But I'm curious about how those elements created in stars ultimately become part of planets and ultimately part of life itself. What's the missing link in this cosmic chain?
That missing link is a fascinating process called chemical evolution, the story of how simple elements combine to form more complex molecules, emergence of life.
Chemical evolution, it sounds almost magical, like alchemy. Tell me more about this cosmic dance of elements.
Okay, so Imagine those heavier elements forged in the hearts of stars scattered across the universe by supernovae. They don't just float around aimlessly, they interact, they combine, they form molecules driven by the fundamental forces of nature.
So it's like a giant cosmic chemistry set with atoms and molecules swirling around, bumping into each other, creating new compounds.
And this molecular dance doesn't happen just anywhere. It occurs in specific environments, like the vast clouds of gas and dust we call interstellar clouds.
Ah, those cosmic nurseries where stars are born. So these clouds are not just filled with hydrogen and helium. They're also teeming with the universe's more complex molecules.
Spot on. And the dust, those tiny particles we talked about earlier, they play a crucial role in this molecular evolution.
Wait, I thought dust was mostly about absorbing and emitting radiation, regulating the temperature of those clouds. How does it contribute to creating molecules?
Dust grains act as catalysts. Their surfaces provide a meeting place for atoms and molecules, facilitating chemical reactions. Think of them as tiny cosmic factories churning out increasingly complex compounds.
So the dust is like a matchmaker, bringing together the ingredients for molecular romance and then providing the venue for their union.
I love that analogy. And this molecular matchmaking is essential for creating the building blocks of life. In these interstellar clouds, we find molecules like water, ammonia, methane, even simple organic molecules like formaldehyde and alcohols.
Hold on, organic molecules? Those are the molecules associated with life, right?
Precisely. And finding them in these interstellar clouds sprinkled throughout the vastness of space suggests that the ingredients for life are not unique to Earth. They're widespread throughout the universe, a testament to the universe's inherent capacity to create complexity.
That's mind-boggling. So these clouds are like giant prebiotic soup pots simmering with the potential for life.
In a sense, yes. Yeah. But it's not just about the molecules themselves. It's about the conditions within these clouds, the interplay of temperature, density, radiation, and magnetic fields, all influencing the delicate dance of molecular creation.
So it's a cosmic recipe with special ingredients, specific requirements for life's ingredients to combine and create something truly special.
Exactly. And over millions of years, these molecular clouds, they evolve, they collapse, and they form new stars, along with planetary systems.
Those prebiotic superpods get stirred up and their contents distributed to newly forming planets, like seeds scattered across a fertile field.
That's a beautiful way to put it. And on some of those planets, conditions might be just right for those organic molecules to take the next step, to self-assemble into more complex structures, eventually leading to the emergence of life.
It's like a chain reaction, a cosmic domino effect, with each stage building on the previous one, leading from the Big Bang's raw energy to the intricate complexity of life.
A magnificent and awe-inspiring story unfolding over billions of years, driven by the fundamental forces of the universe.
It really puts things into perspective. Life on Earth isn't just some random occurrence. It's a product of cosmic history, a testament to the universe's creativity, its inherent drive towards complexity, and, dare I say, beauty.
And it highlights our deep connection to the cosmos. You know, we are not separate from it. We are an integral part of it, woven from the same stardust, driven by the same fundamental forces that govern the universe's evolution.
We've come full circle from gazing up at the night sky with wonder to understanding our place in the universe's grand narrative, a narrative that stretches from the Big Bang's fiery birth to the emergence of life on our little blue planet.
And this understanding, this awareness of our cosmic heritage is not just a scientific concept. It's a profound realization that can shift our perspective, fill us with a sense of awe and wonder, and perhaps even inspire us to live more meaningful lives.
It certainly has for me. This deep dive has been a journey of discovery, a reminder that we're all connected, not just to each other, but to the vastness of the cosmos, to the very fabric of the universe.
And that connection, that realization of our cosmic heritage, is perhaps one of the most significant discoveries we can make.
Well said. I think it's time to wrap up this episode of The Deep Dive. But the exploration, the wonder, it doesn't end here.
Keep looking up at the stars. Keep asking questions. Keep exploring the mysteries of the universe and your place within it.
And remember, you are stardust, a product of billions of years of cosmic evolution. Embrace that connection. Cherish it. Let it inspire you.
That brings us to the end of this journey through the cosmos. Until next time, stay curious and keep exploring the wonders of existence.
Remember, we are not apart from the universe, but a part of it. All is one.
Wow, wasn't that just incredible? The journey from the birth of the universe to where we are now? It's truly mind-blowing. The vastness of the cosmos, the interconnectedness of everything, it really makes you stop and think about our place in this amazing story. And I really loved the part about being stardust. Amazing. But this is just the beginning. There's so much more to explore, discover, and understand. If you enjoyed this dive into the mysteries of the universe, you're going to love what's coming next. So why not keep the adventure going? Check out our other videos. There's a whole universe of content waiting for you. And don't forget to hit that subscribe button so you never miss a moment of the journey. I'd love to know what part stood out most for you. Was there a moment that sparked your imagination or left you with new questions? Share your thoughts in the comments. I read them all, and they really help shape where we go next. Oh, and if you found today's podcast fascinating, give us a like and share it with someone who would love it too. Let's spread the wonder of knowledge together. Thanks for watching, and as always, stay curious, stay inspired, share what you've learned today, and don't forget to subscribe for more cosmic journeys. Together we'll explore the wonders of existence. And always remember, all is one.